All right, today we're going to be using log properties. And to understand the properties of logs, you first have to remember the properties of exponents, which I've written for you right up here at the top of the page so that you can remember what those properties are. Now remember that we use a log to find an exponent. The point of a log is to figure out what that exponent is. Because of that, logs and exponents will play by the same rules. So I've listed those rules here, and we're going to go ahead starting with this first rule, which is that when we multiply the x's, we add the exponents. So I have this example, x to the third times x to the fifth. When we multiply those x's, notice we add the exponents together, 3 plus 5, to get our answer of x to the eighth. Well, with logarithms, we do the exact same thing. So notice here in this example, we have the log base 2 of 5x. Notice that the 5 and the x are being multiplied together. Now remember that when we multiply x's, we can add the exponents. So if I wanted to expand this problem, log base 2 of 5x, I can do that using addition, because multiplication will turn into addition. So notice that the 5 and the x both get their very own logs. We have log base 2 of 5 and log base 2 of x. Both of them got their own log, and then because it was multiplication, we turn that into addition here in between. So if I were to give you a problem and ask you to expand it, that's how you would do it if it's multiplication. So look, for example, here at problem 1. We've been asked to expand this expression. So if I wanted to expand it, I notice that I have the 9 and the x multiplying together. So I want the 9 and the x to both get their very own log. So I'm going to have the log base 2 of 9 and the log base 2 of x. And because the 9 and the x are multiplying, I know that it's going to become addition in between those two logs. All right, well, the next property is when we divide our x's. And notice that when we divide the x's, we subtract the exponents. So we're going to do the same thing with our logarithms. Notice here how we're dividing our logs. We have the log base 2 of x divided by 5. Now if I wanted to expand this and give each piece of this log each piece of this problem its very own log. So x gets its own log and 5 gets its own log. So I have the log base 2 of x and the log base 2 of 5. Now notice that we were dividing, and so I'm going to change that division into subtraction. So, for example, if you look at problem 5 right here, where we have division going on, this is going to become the log base 4 of 4 and the log base 4 of 3. Notice how the 4 and the 3 both got their very own log. And then, because I notice I'm dividing, that division is going to turn into subtraction. So I'll put a subtraction sign in between. Now we always like to simplify our logs as far as we can, and I notice that here I have the log base 4 of 4. So I'm going to think of this as 4 to the what power equals 4. Well, I know that 4 to the first power equals 4. So this log base 4 of 4 is actually the same thing as a 1. So I'm going to replace it with a 1. Minus my second log, log base 4 of 3, that I can't simplify. So I'm just going to leave it as the log base 4 of 3. And this will be my final answer here on problem 5. The very last exponent rule that we're going to talk about, this third exponent rule right here, is when you have a power to a power. Notice how here we had x to the third to the fifth, x to a power to a power. When we do that, we multiply the powers together, and of course 3 times 5 gave us the 15. So we know that when we have powers going to powers, we multiply our exponents. We're going to use that exact same process when we talk about our logarithms. So here in this example, I have the log base 2 of x to the fifth. Notice how I have this power right here, the 5. Now, I know that when I have a power to a power, I can turn it into multiplication. So I'm just going to pull this fifth power down in front of the log and turn it into multiplication. which is how I got this final answer of 5 times the log base 2 of x. So I'm going to use that principle here on problem 4, where it says log base 5 of x to the 6th. I can take that power of 6 and pull it down to sit in front of the log. So it will become 6 times the log base 5 of x. So that's how you're going to do that first section, is you're just going to expand each of these problems, and I'm going to let you finish it. But go ahead and look at this second section where you're now asked to condense the expressions. When we condense, we're going to follow the exact same process. So, for example, if you look here at problem 11, where we've been asked to condense, we have the ln, the natural log of 16, minus the natural log of 4. Now, I want to condense this down to be a single logarithm. And even though I'm using an ln, a natural log, it's still going to play by the same rules. So I'm going to write this as ln, the natural log of, I have my 16 and my 4, and notice how we're subtracting. Now remember that subtraction turns into division. So I'm going to write this as 16 divided by 4. Now I always simplify my fractions if I can, and 16 divided by 4 is a fraction that definitely simplifies because 16 divided by 4 is 4. So if I simplify this fraction, I get the ln, the natural log of 16 divided by 4 is 4. And this will be my final answer on problem 11. All right, well, let's look then at problem 12. Problem 12 is actually using 2 principles here. First, I notice that I have this 2 sitting in front of the log, and I remember that I can pull that 2 up and make it become a power. So this becomes the log of x to the 2nd power plus the log of 5. Now I still want to condense this down to be a single log, and right now it's 2 separate logs. So to condense it down, I'm going to write it as the log, and then I notice that I'm adding, and I remember that addition turns into multiplication. So this becomes x to the 2nd power times 5, or because we typically write the number first, I would normally write it as the log of 5x squared. And this will be my final answer here on problem 12. So keeping that in mind, you can go ahead and try the front side of this assignment.